All right. So from here onwards, we are going to understand the objective and also certain properties of logs. So since we already know the interconversion of, for example, if I can tell you, if you got a to the power x is b, this is referred as an exponential form. So this is exponential form. And so if you go on to write down this in logarithmic form, that's log b to the base a. So that's your basic key element of exponent to log and log to exponent. So if you've been given an equation like this in logarithmic form, you can convert in this form. Or if it is given in this form, exponentially, you can write in log. Now, some of the examples that I can quickly give is if you got 3 to the power x is 5, then x is log of 5 to the base 3. So enough of the explanation I've already given in my previous part as you would have gone through. So now if you got, let's say, 4 to the power x is, let's say, 7, x is going to be log of 7 to the base 4. So here, the logical sense is that if we can understand more data properties of logs, that will help us understand the topic better. Now, before I go to the logs, I would just quickly come to one couple of questions, warm-up questions on exponents. So if you got, let's say, 1 upon 9 to the power of 3x minus 2 equals to, let's say, 3 to the power of 5x plus 2. Now, as exponential relation, if you have got 8 to the power x is 8 to the power y, this gives us x equals to y. This is an interesting relation that exists between two variables. If the bases are the same, the powers can be equated. Now, same way here, if you can see that this right-hand side is power of 3, but left-hand side is, we still can't see anything out here. So if I can write down this as 1 over 9 can be written as 3 square to the power of 3x minus 2 is 3 to the power of 5x plus 2. Now, as an exponent property, also remember if you got a to the power m here, I can write down this as a to the power negative m. These are all maybe fifth, sixth grade properties that we learned. Also, if you got a to the power m to the power n, this is a to the power mn, this property. So if you take it up, so firstly it becomes 3 to the power negative 2 whole to the power 3x minus 2 equals to 3 to the power 5x plus 2. Now, if you see this, the result is going to become 3 to the power negative 6x plus 4 equals to 3 to the power 5x plus 2. So since you can see now, so these two multiply with this property. So now since these two bases are the same, what happened is that I can, so bases are 3 here, so I can just equate their powers with this property. So I can just equate this to powers, which is negative 6x plus 4 equals to 5x plus 2. You correct you collect the x terms together. So negative 11x is negative 2. So you get x is 2 over 11. So this is just a warm-up question on basic properties of exponent, or you can say the general understanding of exponential concepts. All right, so our next property that we have is these are the core properties of logs, I would say. Now, the first property that we have got is if you got log 1 to the any base, if you got log 1 to the any base, it is always going to be 0. Also, the interesting thing is that if you got log a to the base b, now this you can remember that log is always defined only for positive numbers. So a and b both must be greater than 0. So a is greater than 0 as well as b greater than 0 as well as b should not be 1. So this is the requirement for a log term to be defined or log value or log function to be defined. So just this is, I would say, rather than trying to understand this, remember this is a property that I cannot find out log of a negative number. Log of negative 5 to the base 3 doesn't exist. Now, for a reason is, why do we say that this doesn't exist? Let's try to see. If you got log negative 5 to the base 3, assume that if this existed, this is the x value. Let's say this value is x. So if I convert to exponential form, you get 3 to the power x is negative 5, which is not possible because an exponent power cannot ever be negative. You plug any x value you want, but it won't give you a negative answer. So this is why it goes wrong. So here you need to make sure that you both the bases a and b both are number, as well as the base is positive, as well as b should not be 1. Um, Now here, the first property is log 1 to the any base a is 0. That's the property number 1. Number 2 is if you got log a to the base a, it's gonna be always 1. Log a to the base a is always 1. So that's property number 2. So if you've got log 3 to the base 3, okay, the answer is 1. Log 5 to the base 5, answer is 1. Log 10 to the base 10, answer is 1. So that's how you kind of write down the second or interpret the second property. Number 3 is if you got, now this is very interesting. I think one of the most highly used properties in entire logarithmic unit will be this. If you got a power to a log term, so a to the power m to the base b, this can be written as m log a to the base b. So what does it mean is that if you got an exponential term, that exponent can be brought down and keeping the base as it is. So let me give an example. If you wanted to find out log a to the base 3, this I can write down as log 2 to the power 3 to the base 3, because 2 to the power 3 is 8. So this is 8. So this comes down as here. So that's 3 log 2 to the base 3. So I can write down this log 8 to the base 3 as 3 times log 2 to the base 3. So this is an interesting way to solve some of the question. Now, I'm going to take some questions firstly on these properties. So number 1, I'm just going to rewrite the properties. If you got log 1 to the base a is, let's say, 0. Log a to the base a is 1. Log a to the power m to the base b is m log a to the base b. These are the 3 properties. I'm going to work on some sums on this. So first one is, let's say I wanted to find out the value of log of 8 to the base 2. I wanted to solve for what's the value of log 8 to the base 2. So log 8 can be written as log 2 cubed to the base 2. Now 2 can be written, 3 can be brought down. So it's 3 log 2 to the base 2. Answer is 3. So because log 2 to the base 2 is 1 because of this property. So if I wanted to find out, let's say log of 1 over 27 to the base of 3. Now this is one of the common questions that you'll see. So log of 1 over 27 can be written as 3 to the power negative 3. Now why we can write on this is because 1 over 27 can be written as 1 over 3 cubed, which is 3 to the power negative 3. So this becomes negative 3 log negative 3 log 3 to the base 3. So that's negative 3 as answer. So this is basically the exact value based on these properties. So now another example that we have is very interesting example. After I explain these 2 properties is first property is called as product property, and second is the division, you can say. Now, property number 1 is basically if you got, let's say, log of a base, let's say 2 numbers, if they're multiplied with certain base, then this is nothing but log a to the base c plus log b to the base c. So this is basically gonna be the value. I mean, you can write down this. So for example, I've got log 12 to the base. Let's say if there is no base, then it means that it's this. So this means that the base is 10 by default. So this is, I can break this as 3 times 4 if I want. It can be written as log 3 plus log 4. And these values are exactly same. So whether you calculate this on a calculator and you'll calculate this together alone, if you find their values, they're going to be the same. So this is referred as the log property of the product. And what is division property? So if you're finding log of an expression, which is a fraction, This can be written as log a to the base c minus log b to the base c. Now, what does it mean is I can write down this as log of, suppose if you got x squared over 5, I can write down this as log x squared minus log 5. And if there is no base, by default base is 10. Remember that you don't need to write it every time. By default, the base is 10. So you can bring this down here. So this can be written as 2 log x minus log 5. So these are some of the basic skill building properties of the log topic. So now we're going to go to some of the standard level questions that are basically, let's say, if they give us, now this is one of the very, very common question. So if they give us, let's say, if P is log x to the base 2, Q is log y to the base 2, and Z is, or let's say PQR is, let's say, log Z to the base 2. Now, if these are the values of P, Q, and R, and I wanted to find the value of log of x cubed y squared over z cubed in terms of to the base 2 in terms of P, Q, and R. I repeat again, the question is, P is log x to the base 2, Q is log y to the base 2, and R is log z to the base 2. So if P is log x to the base 2, Q is log y to the base 2, R is log z to the base 2. You got to write down this in terms of only PQR. So how do we do this? I'm just going to give you an example and then we can try some questions. So let's say when you're doing this, first one, you can apply the division property. So as we know that log A over B can be written as log A to the base C minus log B to the base C. So you can just subtract the numbers like this. So log, it can be written as log x cubed y squared to the base 2 minus log z cubed to the base 2. Now I can apply product property on this. So this can be written as log of x cubed to the base 2 plus log of y squared to the base 2 minus log of z cubed to the base 2. Now with the power property, you can bring this down. So this becomes 3 log x to the base 2 plus 2 log y to the base 2 minus 3 log z to the base 2. So this becomes 3a plus 2b, sorry, 3p plus 2q minus 3r, because this is p, this is q, and this, I mean, this log z to the base 2 is r. So I'm just going to put those values out here. So this is what exactly particular standard level question look like.